Hello, everyone, and welcome to today's webinar, Protecting the Soft Underbelly of the Data Center. My name is Melissa Russell, and I'll be the host for today's webinar. Before we get started, I did want to let everybody know we are recording this session, and we will make a copy of the slides as well as a link to the recording available in the next day or so. At this time, I'd like to introduce our speakers. I'm joined by Tyson Subsadat, who is our Director of Product Marketing, and Adam Wojak, who's our Senior Sales Engineer. Before I turn it over to you, gentlemen, I also wanted to let everybody know if you have any questions, please go ahead and put them in the Q&A and we will save a few minutes at the end. Tyson, at this time, go right ahead.
Yeah, thanks, Melissa. I'm excited to talk about this topic. I think it's one that will make sense to most people, but maybe something that you haven't really thought of before. Staying with the theme of soft underbellies, you have a cute corgi dog here, but really, we're talking about you want to protect your data center, your server fleet, but actually there is weakness. There's a lot of unprotected attack surface in your data center. I'm going to go over a quick intro of who Eclipsium is, and then we'll get into the topic, and then Adam is going to provide a demo. And we will have an opportunity for Q&A at the end. So if you have any questions, you can submit them through the Zoom interface. Eclipsium, we've been around since 2016. Our founders came from Intel Security. They created like the ChipSec firmware analysis framework. We're headquartered in Portland, and we have a number of large customers in the Fortune 500, as well as government agencies worldwide. We work with vendors such as Panasonic, Lenovo, and Dell. Yeah, let's get into the topic. So inside a typical server, you have somewhere around 30 different types of components that have some type of updatable microcode or firmware. I love the phrase that Adam uses. He says a computer is really a constellation of different computer components. Did I get that correct, Adam?
Yeah.
Okay. So things like the CPU, it has microcode on it. There's firmware on the network card, of course, the BIOS, the UEFI, the SSD. And then one that I learned about is the baseboard management controller. That's in every server. It's connected directly to power, so it doesn't need to go through the boot up process. And it's a little computer inside of your computer. Often it runs a full Linux stack, so it can be vulnerable to these Linux software libraries like OpenSSH and XZUtils. So the BMC is something you ought to be thinking about as well. The point is that there are a lot of components inside of your computer servers. The reason for this, to expand this topic out, is these components come from a variety of different manufacturers themselves. The Government Accountability Office put together a report, and they just used one major OEM provider or manufacturer as an example. They pointed out that this provider has 65 direct suppliers and over 200 second-tier suppliers, and these vendors were located around the world, 39 countries. So it really is a constellation of different components inside of your servers. Now, when you think about your security controls, where do these components fit? If the CIS critical security control number 1, which means it's most important, is the inventory and control of enterprise assets. But how many organizations are doing inventory and control of the components within those assets, even when those components are full-fledged computers by their own right? The second CIS critical security control is software applications. But again, what about the firmware, that is on these different components inside of your computers? Applying, how does this a supply chain security problem? Let me talk about software supply chain security for a minute. I think most people, the problem of software supply chain security is pretty well understood. People understand that you need to be aware of all the open source libraries that you're using and the dependencies on those libraries. You need to be careful about which types of image repositories that your developers are pulling from. And then you need to have mechanisms to ensure the integrity and security of these components as they're being brought together in the CI/CD process into the production application. And then once it's in production, you need to be able to monitor that for new and active threats. So the inventory controls, the hardening controls, the detection controls are all well understood for software supply chain security. But when it comes to hardware, especially the hardware components in your data centers, your network appliances, your virtualization, your bare metal servers that are running your virtualization, your computer servers, there's very little, most organizations aren't thinking about the security controls for those IT infrastructure, the ability to inventory not just the devices, but the assets or the components that go into those devices, being able to harden the things at the component level, and then finally being able to detect threats, things like backdoors, implants, and boot kits and root kits. There's just not, most organizations don't have those security controls. Again, you need to know what's in your environment, not just at the asset level, but you need to know, what components are inside of your assets. You need to be able to identify vulnerabilities and misconfigurations and then fix those. And then finally, you need to be able to detect threats and respond to supply chain incidents. When I talk about a supply chain incident, I'm saying there's a vulnerability or a backdoor discovered in a very widely used component. Say, we all got a big scare with the XeUtils backdoor earlier this year. That software library is used widely in millions of systems, production systems around the world. So it could be a software library, it could be a hardware component, so forth. Yeah. I'm going to talk a little bit about the types of threats that are attacking this level, or you need to think about at this level. You have UEFI boot kits that are available for $5,000 on hacker forums. So that Black Lotus is the UEFI boot kit that I'm referring to. It's a serious threat. Last year, the NSA put out a mitigation guide talking about, well, it's really hard to mitigate this threat because it relies on, it uses exploits a vulnerability that's really hard to fix. Again, they also, there's also threats against potentially baseboard management controllers. If the attacker can get access to one of those, they could spread laterally throughout your management network. And then there's things like the XeUtils backdoor. We don't know how many other APTs or well-funded persistent threats are trying to insert backdoors into the different components that we have, whether it's commercial or open source. I specifically saved the attacks against network devices for this slide. Basically, we put together a short history of threats against network devices from the first Cisco rootkit in 2005 until just in the past few years, it's really ramped up. Last year, at the end of last year, you guys may remember about the Citrix bleed vulnerability, and just multiple threat actors were just going after that, including a lot of ransomware threat actors. They were using Citrix Bleed to compromise organizations like the shipping giant. I think it's DH World, or then Boeing. And then there was a Chinese commercial bank that got compromised by ransomware. So this year, we've seen multiple very dangerous vulnerabilities centered around OS command injection in Avanti Connect Secure, Palo Alto networks, like their firewalls, and then Cisco devices as well. So much so that CISA put out an alert asking manufacturers to please check their products and eliminate this class of very dangerous vulnerability as they are being actively exploited. Adam, you have experience with misconfigurations. Do you want to talk about the types of misconfigurations that we found?
Yeah, we can talk about that. So one thing Eclipsium can do is look at your server fleet and track misconfigurations at scale, right? So looking into things like secure boot, direct memory access, firmware rollback from the various different vendors. But this is kind of a unique one or interesting one, and that's really Intel SPS or ME, end of manufacturing or manufacturing mode, you may hear it referred to as. So late last year, actually our detection engine, which we call Automata, turned up a case of this in a POC where some Lenovo servers, specifically SR670s in this instance, had been being manufactured without manufacturing mode completed for almost, or maybe even over a 2-year period. So what that really means is there were debug tools that were left on that could potentially allow firmware to unintentionally be overwritten, malicious firmware to be written. There's potentially keys that are unfused. The good news in the case of servers is there are other protections in place with this, but this applies also to, and I should say that depends on the processor, right? So with Xeons, there's typically other protections in place, not so much your Pentiums and other processors, but on desktops, this would be called Intel ME, right? The management engine, and you generally don't have those protections. So this is kind of an interesting one. Another thing to note on this, I guess, is so again, we can detect this at scale, which is unique. There's also multiple tools out there that are kind of one-off detections for this. And as we were, basically making sure this wasn't a false positive, we found that most of those tools were wrong. It was really only our own tool and Intel's tool, as well as ChipSec, which was written by our founders, that got the correct result here. So really kind of interesting.
Thanks, Adam. Yeah, so I think what this case highlights is the need for third-party assurance. It's good to trust your vendors, you should, but you also need the mechanism to be able to verify that things are going well. I want to talk a little bit about the types of vulnerabilities that can occur at the component level. Here are three vulnerabilities that Eclipsium has discovered. We discovered a backdoor that was in Gigabyte motherboards. Gigabyte put it in there. They could, update the firmware, but also it was vulnerable to malicious actors taking advantage of that. I think it was like HP ILO or some other baseboard management controller had firmware vulnerabilities that were also very, very worrying. And then earlier this year, we discovered vulnerabilities in the Phoenix UEFI BIOS, and that is manufacturers, they often don't create their own UEFI. They buy it from a third party like Phoenix or AMI. And anyways, this one has the potential to affect millions of models that we use every day. We've been talking a lot about baseboard management controllers because this is a webinar about data centers and you have a lot of them. these BMCs in your environment. The the NSA and CISA had a great paper that they put out last year, and I'm just going to read this quote. Traditional tools and security features, including EDR software, IDS, anti-malware, kernel security enhancements, virtualization capabilities, and TPM attestation are ineffective at mitigating a compromised BMC. That's because the BMC is a little computer that has direct, power, and it totally subverts everything that's going on in your normal computer, the computer that it's attached to. So it's just something to kind of emphasize to you all that this really is a soft underbelly. It's like your data center is a cute little corgi with so with that, yeah. So that's why Eclipsium exists. We know that attackers understand the supply chain is incredibly complex. If they can insert a threat at this level, it's very hard to detect, and they are going to potentially compromise, thousands or millions of organizations. Eclipsium provides two products. We have a supply chain intelligence guide, which is sort of like a feed or an interface into our backend reputation database for components. You are able to query this guide and get risk information on products, components. You can see, compare, for example, two laptops from different vendors and compare their risk score. You can tell your procurement team that, hey, anytime we buy a laptop for a designer, I don't care which vendor you buy it from, but it has to have a risk score of under 20, for example. Or you could say, for this component, I want to see in which products it's used. Maybe there's something in the news in the morning, and you can quickly be able to answer the rest of the organization about your what's your risk exposure. The second offering that we have is our supply chain security platform, which is kind of like our flagship product. And this monitors all of your devices in production. So we have different mechanisms to scan the different devices, client PCs, servers, network devices, virtualization, and look at everything at the component level and tell you what's in there, how vulnerable it is, and are there any threats? Okay. And so before we do a demo, I just want to give a quick pitch for anybody going to Black Hat. We do have an happy hour. We'd love to have you with us. It's going to be at Strip Steak on Thursday, August 8th. And we do have one of our security researchers, Vlad. He's going to be speaking also on Thursday, August 8th, about vulnerabilities that he's found in F5 Big IP Next. So make sure to be at those events if you're going to be at Black Hat. And with that, I'm going to turn it over to you, Adam.
Great. Thanks, Tyson.
Yeah.
I'll bring up my screen here. All right. And can everybody see can you see my
Yep.
font?
Yeah, it looks great. Yeah.
Perfect. Thank you. So I think I'll show you a couple different kind of scenarios here, and then I think we're going to open it up to Q&A. So if we have any additional questions, kind of demo related, I will do my best to walk through and answer any of those questions as well. So with the Mind on Data Center today, I'll kind of focus on that. So what we have here is basically our dashboard, our landing page of the Eclipsium supply chain platform, security platform. You can see we've got 392 total assets. There's really 3 asset classes those are covering, which you can see here in the center towards the left, that basically clients, servers, networking devices. On the bottom, we're going to break each of those or all of those devices down into what they have for threats, vulnerabilities, currency of versioning, and then what we call firmware integrity baselining, right? So if you set a baseline that you want to map devices to, then we can track the where that's at. So first off, again, focusing on data center, we'll just click the server slicer here, and we'll see we have 36 assets servers, and then we can see that the threats and vulnerabilities and et cetera update accordingly. I'm going to drill down again into Lenovo here. We're down to 4 assets, and then we can basically, continue to drill down and investigate any of those. In this case, let's maybe look at these high vulnerabilities. All 3 of those systems that have high vulnerabilities, we'll get the list of those devices, some high-level information about them, and then we can continue to just drill down further into that. So today we're going to look at a SR670 V2, which we kind of spoke about earlier. You're going to see your basic, what we call inventory metadata here, right? Name, DNS host name, MAC addresses, IP address, etc. Just basic information about the device. On the right side, you have a little bit of configuration and control. All of these things can be done at the device or group level, or in some cases, even globally. But the first kind of security related information here is the Intel Transparent Supply Chain certification. So basically, we participate in a partner program with Intel to read their TSC data, and so does Lenovo. So when Lenovo completes the manufacture of a device, they store essentially the manifest of that configuration in the TPM. They also upload it to a Intel database. And then when we scan that device the first time, and really every time, we can determine whether that device matches the Intel TSC database. In this case, you can see that it's failed. It's, depending on the life cycle of the device, that may be a concern. Obviously, one of the benefits of this is making sure that you receive the device in the same state that it was manufactured. So this one's in production. It's been, the BIOS has been updated. Not a big concern, but at least we have that information, right? Next, we're going to have just a list of vulnerabilities on that device, right? That's going to be sorted by the CVSS severity. And then you can look at these. You could drill down into each of these and find out more information. But, you can see on this device, we see both logo fail and PXE fail, which, could potentially allow, in the case of logo fail, like a secure boot bypass, PXE fail. If you're network booting IPv6, you could potentially have some remote code execution or et cetera. Outdated DBX, you may have secure boot enabled, but your DBX isn't current, meaning your forbidden keys haven't actually been updated the database. So again, there could be a secure boot bypass scenario there. And then this was the device we were talking about where we saw the Intel ME manufacturing mode, or really it would be the SPS. We'll drill down into that a little deeper here in a second. Next, you're going to see the UEFI version firmware of the overall server, the currency of that versus what's installed versus what's available on the device, right? So you can see the specific version installed. You can see what date that was released, and then you can see there is a newer version available. This is the release date. This is the version. We do provide a feature called automatic firmware update. So you could potentially update the firmware of the server directly from our console, push that to the device. We repo that, evaluate that firmware and everything before you ever push that out. You could expand this and get some additional detail. We'll generally have what CVEs are addressed by the firmware, and then you can see the bundled updates here, like the NVMe and SATA drive firmware. This is the view I like because, we're really talking about that deeper level component inventory and security assessment of your data center servers, right? So I like to look at it from this point of view where I can see which of the components within that server are vulnerable. So as I mentioned, we'll look at that Intel ME. I guess you've probably noticed by now, but we use a traffic light protocol, right? So green is generally a good state. You can probably ignore that device unless you're specifically looking for detailed information there. Yellow is a little bit more of like a warning level. And then if there's an actual threat or indicator of compromise, you would see those show up in red. So let's drill down into that Intel SPS. You can see we're going to provide overall information about this component, right? So you can come down here and see version information, kind of detailed information about that device, previous scan history. But you're probably going to be looking for more information about that vulnerability when you're seeing this. So you're probably going to come here and drill down into that information. We're going to provide you a summary and overview of what that actual vulnerability is. We'll provide any recommendation as far as how to remediate it, how to maybe mitigate it, and then of course link out to additional resources about that concern. In the case that you can't mitigate it, you're waiting on the vendor, or it's not a concern because of you have already mitigated it. You can choose to mute that so you're not continually alerted about it. Another nice aspect is we will show you on this screen regarding the vulnerability, any other devices in the environment detected with that same vulnerability, right? So you can quickly get a list of devices that you need to remediate. So let's see, let's go back here. I guess I'd like to also point out that part of inventory and understanding what you have is building those software bills of material, right? So we're going to do that automatically for each device when we scan it. You can click this link here and you can download that in either the common SPDX format or an HTML format. If we have recommendations about the device, we'll show those here for you. And then security configurations. So in this case, you see secure boot is insecure. So it's either not enabled or not securely configured. And you see SMAP and such as well. Let's see, we got a few more minutes here. So yeah, I also want to show you, I guess, let's say you have a mandate to find all the devices in your inventory that are affected by a particular vulnerability. So in that case, you may want to just start with the overall inventory, right? So I'm just going to go to assets and asset list. We're back to that 392 total devices, including desktops and everything. I can click that hamburger menu there and expand my asset filters. And then what we're going to do is I'm going to use TPM's Trusted Platform module as an example. So we can come down here and filter on that. If you noticed, we're down to roughly 150 devices. Not every device in the inventory has a TPM. But in this case, let's go down to a specific manufacturer. You may remember that Infineon a few years back had some vulnerabilities associated with certain chips they released. So we could click on Infineon. We see we're down to one page of devices here. I think it's around 30. But really, again, we care about servers, right? So we could slice it by servers. And we can see that, okay, we actually have 3 servers in our environment that have Infineon TPMs. And at this point, you could just, export that list. You can actually from here, you could go and add that to a group to track remediation, either a new group or existing group. You could schedule a new scan just to make sure that that scan is recent and all the data is accurate. But basically, you can work with that list of devices to correct the issue in that case. So I'll leave a couple minutes here for questions.
Very cool stuff, Adam. There were some great questions on the chat. Somebody asked about for a lot of these component level vulnerabilities, do you need to be like chain with another vulnerability exploit in order to get to them, or can they be like unauthenticated remote code execution? I answered that in certain instances they can be. I think if it depends if that component or device is like reachable from the whatever network they're on. Did I get that correct?
Yeah, I would say so. I mean, I would say experience kind of tells you the worst attacks are generally like a catastrophic failure, meaning like a chain of events or a chain of exploits are used to, not just compromise one device, but move laterally into others or deeper into that device or et cetera. So one single vulnerability could, there's single vulnerabilities that can obviously provide privilege escalation, remote code execution, secure boot bypassing, et cetera. But generally it's, a series of unpatched things where it gets really nasty.
Okay, thank you. Robert had a question about, are we just relying on integrity checks and signatures? And I replied about the automata. Automated binary analysis system is doing static analysis and methods where it will detect malicious behavior. And then Robert had I don't know if you can, because you're sharing, you might not be able to see the Q&A panel, but
Gotcha.
Robert also had a question about, could the agent be subverted? So could our sensor be not as reliable after some type of like spy flash? Um,
Yeah, that's a great question. And I'm probably not prepared to talk about specifics of that, but we do have mitigations in place, signatures and such, certificates, et cetera, to ensure that the driver and the agent running are ours, and that the data is transmitted back is coming from those. So that's something we could follow up. If you want to reach out to us, we can have a deeper conversation about that. But
yeah. Yeah. So there were a couple questions about does this require agents? And the answer is it depends. In most cases, we do want to install the sensor. Adam, do you want to talk about some of the options available, especially in the context of a data center? Because some people might have concerns about adding another agent to their production servers.
Yeah, it's a great question. I hear a lot. So it does depend. It depends on the device. It depends on the operating system running. So if we're talking servers specifically, if you're running a Windows or say Linux-based operating system, we can install an agent typically on those devices. That's going to give us the richest data, if you will, the highest fidelity, really allow us to check security and threat in those devices pretty deeply. We do have the ability to scan most of those devices remotely as well. So there's a few different scenarios there. Say you're running a hypervisor like VMware, ESXi, we could scan the vSphere SDK and get information from that. We can also scan against BMCs and Redfish. Neither one of those is going to provide quite the depth of information of an actual on-device agent, but those are options. And then really, when you're talking data center, you might be talking, network top of rack switches, core routers, those kind of things. We have the ability to assess those as well, and those are almost always going to be a remote authenticated scan of those devices, where we're going to collect the config data and firmware from that device. And then as Tyson mentioned, all of the real analysis is going to happen off box, if you will, right? Not on your hardware, but on a instance that stood up for you, where our analytics engine is, and it's going to run through all those things Tyson was talking about. Similarity scans, integrity analysis, heuristic scans, just Yara pattern matching rules, right? And doing that static and dynamic analysis, as he mentioned.
Yeah, thanks. Did you talk about scheduling and the
Yeah, as far
ephemeral,
as
like
as far as
the ephemeral agents that can,
Oh, no, I'm sorry, I did not. So yeah, good point. So I guess when does it run? How does it run? We typically are going to run on boot in a data center where devices aren't rebooting regularly. You have full control over scheduled scans, right? So if you want that to run weekly, daily, whatever that period is, you can control that. Yeah, we do have ephemeral agent based scans, right, where you could have that out on a network share or something, or where it's executed remotely and scanned versus actually the agent residing on the device. It's it's very lightweight. So one thing to think about, we're not like a antivirus or anti-malware where we're interrogating the entire file system. We're really looking at specific security components. The amount of data that's there is usually pretty small. We're extracting the firmware, pulling some PCI config space information, UEFI, TPM, config registers, and et cetera. And that all takes, a couple minutes to run and uses a very small percentage of a single core to do that. At that point, we bundle it up and we, as I mentioned before, we ship it off to an analytics server that's stood up on your behalf.
Just a couple, lots of great questions coming in. Somebody had a question about where are the SBOMs coming from?
So we are generating the SBOMs. So when we scan the device and we collect that all the information, then we're building that SBOM. So I don't know if that answers your question, and maybe there's some confusion there because we're not looking at, you know, SBOMs in the more traditional sense of like applications, like operating system layer applications, user applications. We're looking at the software that's running within the firmware, the libraries in the firmware, if you will, and building SBOMs for that. So maybe that provides clarification. If not, happy to dig a little deeper.
And somebody had a final one. Somebody had a question about are these realistic? Are you know, how often do these types of compromises happen? And I answered, we actually have analyzed or taken a look at the CISA's known exploited vulnerabilities database, which is a small subset of all the known, all the vulnerabilities in the NVD. And surprisingly, a large number of those are in firmware. Now, you also have to think that you know, embedded OSs are considered as firmware as well, which Eclipsium can help with.
Absolutely.
So,
Yeah.
yeah.
Can
Okay.
I add a little bit to that, Tyson?
Yeah.
So really, actually, 3 out of the last 4 years, firmware has been the largest category of known exploited vulnerabilities. And I always like to point out, I'm sure most everybody on this call realizes that these things are remotely exploitable these days, but you really have to think there's been a lot of things done to ease the burden on administrators, right? Like allowing you to update the firmware through the local operating system or remotely via BMC and those kind of things. But that's also making it easier for the threat actors, right? That's given them an attack vector and an avenue to do, you know, the same thing in a malicious nature. So
Adam, I wanted to ask quickly, can you show you showed about like secure boot and all the misconfigurations on that one Lenovo server. Is there any way to look at it? Can you show how you would look at it across your fleet?
yeah. So good question. I did mention we can do those misconfigurations at scale, right? So so actually here under our supply chain category, we have a security configurations section. So this is kind of neat because we are tracking, you know, the overall security configuration of all your assets, right? We're going to show you your top misconfigurations, your top misconfigured assets, if you will. And then we're really going to break it down into each of those categories and show you how many devices are insecurely configured or just plain don't support that feature, right? So I always kind of default to secure boot. We'll drill down into secure boot here. You're going to by default get a list of insecurely configured assets. You see we got about 60 devices or in that neighborhood that are insecurely configured. But again, we really only care about servers. So, you know, we can change that list. We get a list of devices with secure boot, either not configured or misconfigured, and we can work with that data from there.
Great. Okay, I think yeah, thank you everyone for you know, interacting with us and asking great questions. Melissa, I know we're over time. Do you want to?
Yep. I want to thank everyone again for joining us. Tyson, Adam, thanks again as well. Again, we did appreciate everybody joining us today. We will be sending out the recording and the slides, and we hope to see you on our next webinar, which will be taking place on August 1st on vendor risk management. So can't wait to see you there.
Okay.
Thank you.